When engineers first begin working seriously with large language models, one of the most confusing experiences is that prompts which appear perfectly clear to humans sometimes produce answers that are vague, wrong, inconsistent, or strangely structured. Many people initially interpret this as randomness or unreliability, but in reality these outcomes usually arise from predictable mechanisms inside the model and predictable weaknesses in the prompt itself. Understanding these mechanisms is essential for anyone who wants to move from casual prompting toward disciplined prompt engineering. The most important shift in thinking is to stop treating a language model as if it were a person reading instructions. A large language model is not interpreting intent in the way humans do. It is performing probabilistic token prediction conditioned on the text it has already seen in the conversation. The prompt is therefore not merely an instruction, it is the statistical environment that shapes the probability distribution of the next tokens the model will generate. If the environment is ambiguous, incomplete, conflicting, or poorly structured, the model will still produce an answer, but that answer will reflect the statistical signals available rather than the intention the author had in mind. Because of this, many prompt failures are not failures of the model but failures of the prompt to establish a sufficiently strong statistical context. These failures tend to fall into recurring categories that become easier to diagnose once you recognize them. One common failure mode is underspecification. In this case, the prompt leaves too many variables undefined. Humans often fill in missing context automatically because we rely on shared background knowledge. Language models cannot safely assume which interpretation the user prefers, so they default to the statistically common interpretation observed during training. If a prompt says explain this algorithm, the model must guess the level of explanation, the audience, the scope, and the format. Should the explanation be mathematical, conceptual, or code-focused? Should it assume beginner knowledge or expert knowledge? Should it be concise or comprehensive? The model will choose some answer, but there is no guarantee it matches the user's intention. The failure arises because the prompt failed to define the problem space clearly. A closely related failure mode is hidden ambiguity. Even when prompts appear clear, they sometimes contain words or phrases that can be interpreted in multiple ways. Technical terms are particularly prone to this problem because they often have domain-specific meanings. Consider the word model. In machine learning, it may refer to a trained neural network. In statistics, it may refer to a probabilistic representation. In software architecture, it might refer to a component in a system design. A prompt asking for the model architecture might therefore produce different answers depending on which interpretation the language model statistically associates with the surrounding words. Ambiguity increases entropy in the probability distribution, and the generated answer may drift in an unintended direction. Another frequent failure mode arises from conflicting instructions. When a prompt simultaneously encourages different output styles or goals, the model must reconcile them statistically. For example, a prompt might request a detailed explanation in 2 sentences. Humans immediately recognize the contradiction. The model will still attempt to satisfy both constraints, often producing an answer that is neither truly detailed nor truly concise. Similarly, prompts that request both creativity and strict factual precision can create tension within the generation process. The model's training contains examples of both tasks, and if the prompt activates both patterns simultaneously, the output may oscillate between them. A more subtle failure occurs when prompts rely on implicit reasoning steps. Humans often compress instructions because we assume the listener understands intermediate steps. For instance, a prompt might ask the model to analyze a complex dataset and provide conclusions, but without specifying how the reasoning should proceed. In such cases, the model may jump directly to a conclusion pattern it has seen in training rather than performing the analytical steps the user expected. The result can appear as shallow reasoning even when the model is capable of deeper analysis. The issue is not the capability but the absence of an explicit reasoning scaffold in the prompt. Another hidden failure mode emerges from format uncertainty. Language models strongly respond to formatting cues because training data contains patterns linking certain formats to certain tasks. If the prompt does not specify the desired format, the model must infer it. A request to compare these algorithms might result in paragraphs, a table, or a bullet list depending on which pattern is statistically activated. This unpredictability becomes problematic in professional settings where outputs must integrate with downstream systems or documents. A particularly important failure mode is task blending. Many prompts unintentionally combine multiple tasks that are better handled separately. For example, a prompt might ask the model to research a topic, evaluate the sources, synthesize the findings, and present strategic recommendations all in one request. Each of these tasks requires different reasoning patterns. When compressed into a single prompt, the model may shortcut the process by generating a plausible high-level summary without truly performing each step. Decomposing complex tasks into staged prompts often produces significantly better results because it reduces cognitive compression inside the model's generation process. Another common problem arises from context dilution. Large prompts sometimes contain extensive background information, but not all parts of that context carry equal importance. The model does not inherently know which sentences matter most. If key instructions are buried inside large paragraphs, they may receive less influence on token prediction than expected. This occurs because attention mechanisms distribute weight across the context window, and weaker signals can be overshadowed by stronger linguistic patterns elsewhere in the prompt. Prompt failures also frequently arise from the model's tendency toward completion rather than verification. Because the training objective of a language model is to produce plausible continuations of text, it is optimized to generate answers that look correct rather than answers that are guaranteed to be correct. When a prompt asks a question for which the model has uncertain knowledge, the model may still produce a confident answer because that pattern is common in its training data. This phenomenon is often described as hallucination, but from a mechanistic perspective it is simply the model following the statistical expectation that questions are usually followed by answers. Another hidden failure mode is instruction overshadowing by examples. Many prompts include examples to demonstrate the desired behavior, which is often effective. However, if the examples contain stylistic or structural elements that conflict with the written instructions, the model may prioritize the examples because they are stronger statistical signals. For instance, if the prompt says provide short answers but the examples show long paragraphs, the generated output will likely resemble the examples rather than the instruction. In prompt design, examples often function as more powerful guidance than descriptive text. A further complication arises from distribution mismatch. Large language models learn patterns from massive corpora of text that reflect common writing styles and tasks. When prompts describe tasks that are rare or unconventional, the model may struggle because it has fewer training patterns to draw upon. The prompt must therefore compensate by providing clearer structure and stronger constraints. Understanding these failure modes leads naturally to the concept of prompt anatomy. High-quality prompts tend to share a set of structural characteristics that reduce ambiguity and increase the probability that the model generates the desired output. These characteristics do not represent rigid rules, but they provide a mental framework for designing prompts that align more effectively with how language models operate. A well-constructed prompt usually begins by establishing the task identity. This means clearly defining what the model is expected to do. The task identity should be expressed in a way that activates a recognizable pattern within the model's training data. For instance, stating that the model should act as a technical reviewer analyzing software architecture creates a strong contextual signal about the type of reasoning and language style expected. Following the task identity, high-quality prompts often define the objective. The objective explains the purpose of the output rather than just the action. This distinction matters because it guides the model toward the end state the user wants. If the objective is to help an executive understand a technical issue, the explanation must be different from one intended for engineers.
If you find this video exciting, please like, subscribe, and turn on notifications. See you in the next AI for Beginners educational video.